Hi everyone. So my name is Nicolas Rod. I'm a software engineer at Google. I worked on Android for the last several years, mostly on the web view and the browser. But this past year, I've been working on a photo editor in the gallery application. So I'm going to talk about image processing on Android, and it seems like there is a problem with the slides. The slides are cut. So, no. There you go. Thanks. So basically, what do we want for image processing? We want everything, right? We want it to work well everywhere. It needs to be fast. Needs to be using as little memory as possible. Basically, we want to have our cake and eat it as well. So the Android KitKat photo editor that we just released, and hopefully a few of you can play with it on your Nexus 5 or with KitKat that I believe just started to roll in today. So the photo editor supports non-destructive editing. We also do full-size image processing. There is surprisingly not a lot of editors that do that. It takes more. You need to be more careful about the RAM usage and etc. So, and the big idea is that we can combine effects as you want when you edit the image. And the general concept was to build something that was very easy to use, but at the same time, if you knew what you were doing, or if you were simply learning more about image processing, the application will grow with you and will have all the things you want. So when I speak about non-destructive edits, basically this is the concept of you apply something on an image, but it doesn't destroy the original image. So you can go back, change that. Let's say that you apply some contrast. You go back and you can reset it to 0. You will not have any loss in quality. The second thing is that often, when we talk about non-destructive edits, we talk about allowing you to re-edit an image that you already saved. And I'll talk about Renderscript in this presentation. For now, just say that it's something cool that lets you do image processing fast. Very briefly, I'll highlight what we did this year. So the first version of the photo editor, which actually was already bringing a lot of the general concepts and the UI and what you could do, was out with 4.2 last year. We then worked on the G+ editor in the G+ application on Android. Then in July, we continued working on our editor. We improved, we added more tools. We moved more to Renderscript. And finally, we just released the last version of the editor with KitKat. The notable differences with KitKat is that we finally enabled pinch to zoom, so you can actually look at your image and not just be seeing the full image. And we also allow you to re-edit an image that you save. So you open an image, you process it, let's say you turn it to black and white, you can open it again, and you will still be able to change the effect that you applied, or even go back to the original image. So here is a quick demonstration. So basically here, I'm just opening an image in the editor, and you see that you got those different looks that you can apply easily on an image. So those are presets that are pre-baked look. You can always compare to the original image. You can, of course, zoom in. And if we go to the next session, you can apply borders. You can, of course, do various geometry stuff like straightening or mirroring. And then there is the final tab, which is, to me, the most important or more interesting one, where you have all the more isolated effects. If you click on Applied Effect, you see all the effects currently applied in the pipeline. And you can use it to remove an effect or to navigate, like we just did with contrast. So we got a couple of new effects that are pretty cool in the last version, like the saturation per channel. We have a local edit as well that lets you easily select part of the image and only apply an effect only on those parts. The usual vignette tool, which is pretty nice. You can move it around. You can also apply, like you can play on the saturation and stuff like that. Curves, which actually was already there in the first version of the editor, and it works again on all the channels for the colors. And more interesting effects. Another thing that we added in the last version was the ability of, so when you save, just to go back quickly, when you save, so the image is applied, it's a normal JPEG. If you re-edit it, you still have access to the original image. And you can see all the currently applied effects, and you can reset and do other things. So one thing that we added recently is also the ability of saving your own presets. So here I'm just building a quick look that I like with a black and white filter and a vignette, and I'm going to save that. If I exit now, and you see it's in my list of looks. If I exit now, we haven't saved, so we just go back to the original image. But, so let's reset it. If I go down, you see the effect I just said. I can apply it, save it, and everything will work. The nice thing with that is that if you have a common processing that you like, you can reapply it easily on any image you want. And that's that. So for the demo, so just a couple of additional things. It works here. That was on the tablet on the Nexus 7. It of course works on the phone. The filters were originally written in a native in C, and this past, during this past year, we tried to move toward Renderscript. It works on potentially really large images. The largest I tried was the 278 megapixel image, which might not be the more common size for images, but it just tells you that, yeah, you can process images that are pretty large. That's fine. And something that I'm really happy about that is that we managed to get nearly all of the editor in the Android open source project. So if you want to see how things are done, you can just go and look at the source, and that's it. So, so when we talk about image processing, basically we want something like that, right? We have an original image, we want to do some filtering, and we get a processed image. So how do you do that on Android? Well, you have multiple choices. You can do it in Java, or you can do it in native code through GNI, or in OpenGL, yes, with shaders, or in Renderscript. So in Java, well, you get a few APIs like get pixels, copy to pixel to buffer, and stuff like that. In general, that's not a good idea to use Java. You're going to have a lot of issues with garbage collection, and garbage collection, particularly when you want to do interactive processing. I mean, you don't want the user to wait, and when an effect is applied, you want something to be as fast as possible. Java is not going to be great; it's going to be slow, plus the garbage collection. So, not a good idea. Maybe for prototyping, but that's about it. Native code is actually not too bad in terms of difficulty of dealing with it. It's you pass just a bitmap object to the native side. Under the hood, it's actually just an array of bytes, so it's pretty easy to manipulate. But you got the problem that dealing with native brings, which is, well, it's not going to support easily multiple architecture. It's going to be annoying. You have to deal with GNI, etc. OpenGL is another one of the common path. And it's pretty cool because, well, usually you can do something really fast, so you can get interactive processing. You do run into issues with making sure that all your code will run well on all devices. Sadly, there's a lot of differences in performance between different GPUs and GPU vendors. So if you do something that works well on one GPU, that particular optimization might not work so well on a different GPU, etc. You also have limitations like, I mean, that's one of the reasons a lot of photo editors on mobile have a limit to 2048. It's because that's the max texture size on many, many GPUs. The other problem, and that depends what you do, and that may be fine with what you want to do, but is the fact that you have to write your code. It kind of is fixed, right? You can't just so easily apply shaders after shader after shader because you'll run out of GPU time. So that kind of means that you are going to write one shader or one big shader, and that's the extent of all the processing you will do, which, depending on what you do, might be perfectly fine with your goals, but that's one of the constraints. And of course, because it runs on the GPU, it might be pretty expensive to retrieve the processed image. So Renderscript. So Renderscript, yeah, this is how we explain it on the developer page. It's not super clear. So basically what that is, it's a C99 language with vector extensions and some nice intrinsics. That means that you can write code that is much clearer, that takes less space than what you would do in Java or any other languages. It's actually also pretty close to the GLES shader language. So if you know GL shaders, moving to Renderscript is actually pretty easy. It does execute, and you have the choice on the GPU or the CPU. For the GPU, it needs a driver, and we do have drivers for all the Nexus devices. But yeah, it might not run on all the devices, on all the GPUs out in the market, but that's something that the team is working on a lot. The really nice thing to me, and that's the main reason originally we switched to Renderscript, is the CPU backend that they have is actually really, really good. It executes all the instructions in parallel. It takes advantage of all the cores on your device. They do optimization through LLVM. Basically, it's a really, really nice native implementation. What I just said. The nice thing as well is that it runs all of that in the background thread, so it doesn't block your UI. There is some issues with it. You can't allocate memory directly from the Renderscript kernel. And in general, the approach is that Java is where you actually manage the memory and is where you control the execution of Renderscript. So that's some constraints. But depending on what you do, that may or may not be a big constraint. For image processing, it's actually not a constraint, because usually we do have all the allocation already done in Java, and we just pass them to be processed. The really nice thing as well is that we finally released the compatibility library, which means that if you write Renderscript, you can actually execute your application. I think we went back to Gingerbread. But we did run it on Proyo just for the sake of it, but probably not a good idea. But so it's really nice. You can write once, and it will run everywhere. In terms of performances, so those are common effects that Renderscript provides, like a blur and a convolution. And you can see the performance compared to multi-threaded C code. So do realize that if you do write NDK code in C, most of the time you're probably not going to write it multi-threaded. So yet, even if so your usual code written in native is probably going to run even slower than that. But even with a multi-threaded code, Renderscript is much faster. The other really nice thing, at least from a developer's perspective, is that Renderscript improved over time. So here you see the performance increases on the different versions of Android. So that's because they basically do the optimization through LLVM. You don't have to do anything, and your processing will be much faster over time. And just a quick comparison between the different possibilities. So the big blue bar is Java running not multi-threaded. Red is Java multi-threaded with 4 threads. Yellow is NDK with not multi-threaded. And green is NDK with 4 threads as well. And the very, very small numbers below are Renderscript with the CPU, and the one even faster is Renderscript running on GPU. So it's a really compelling alternative to the NDK. They achieve those results by having an optimized mesh library. They also do optimization on the device. And you can actually also specify the precision that you want and stuff like that, which can have a lot of impact on the performances. So the way it works is that you create allocations, and it's basically it's basically an area of memory that the scripts are going to interact with. You can do some interesting optimizations like that. You can actually bound an allocation to a surface texture, which means that you can avoid a copy between, you can run, in an ideal case, you can run everything on the GPU without passing back by the CPU. The other nice thing is that you can easily share memory between allocation and bitmap, so you don't have to incur the cost of having a double memory simply because you want bitmaps being processed. So to use it, you basically create a script. So here I'm just creating a very, very simple function that returns exactly what it takes in input. You have to specify a version number. Right now it's only one. And the class, the package name for the class that will be generated. So you write that script, put it into an RS file, and the toolchain will basically generate a Java class that you can interact with. And when you can see the function itself is very straightforward. It basically is a C function with just an attribute saying that it's a kernel, which means that it's something you'll be able to call from Java. You can also create functions in Renderscript that you can call in the kernel. Then you create a context, pretty straightforward. Here, I'm allocating an instance of the filter that I just created. So you see that the script C_filter class, it's something that has been generated automatically. Then I load my bitmaps directly from the resources. Those are not just normal bitmaps. And then I create the allocations on those bitmaps. And here I'm saying, okay, make them so that they will be used by the scripts and make them so that the memory used is the same. And finally, we just apply the script. So we just call for each on the color function that we just declared, passing an input allocation and an output allocation. And at the end of it, I do out.copy2 from the allocation to the bitmap. And because the memory here is actually shared, that will simply be a no-op if the processing is already done, or it will just be a sync point. And that's basically what we get. Those are nice things that Renderscript provide script intrinsic, so those are basically script objects that are already there. So the way you use them is exactly the same way as your own script. You create an instance, you can set parameters, and then call for each. And you get from there to there. So you have a few interesting intrinsics that get all the common operations, like blur, blend, the color matrix, and so without doing, even if you do not do any of your own script, you can already use those to create pretty nice effects. So let's do something a bit more interesting with this script than just returning exactly what we take. If I want to transform this image in black and white, I can simply access the vector that is passed to me in input, setting the components, green and blue, here to the same component, red. So that's something that's really nice with Renderscript, is that you can access those vectors via you can basically call them RGB or even XYZ. It's pretty flexible. You can do stuff like that, where you just say, okay, just set all the channel G and B to R. And you end up with a black and white image. So just for comparison, this is what you need to do in the NDK. You need to log the pixels, you need to iterate. It's not as nice and it's not as clear as the Renderscript code. And also, it's not multi-threaded, it's going to be much slower. So if you want to do a bit more than just a global pass on your pixels, if you want to do some effect like that, for instance, where you want to just apply a gradient over your image. So if we start with the script that we have, you just have to change the signature of your function by adding x and y. And then you just, let's say we just compute a float, that's the range that we are applying, and compute the color that we want depending on that range, and then setting that into the pixel that we work on. If you want to do a bit more, doing mixing colors like that, you can simply reference the input and just have a nice effect like that. As I said, you can access the different channels in a more straightforward way. So you can also work with the pixel as floats rather than integers, which is probably what you want to do because you'll get a lot better precision. So you have to unpack the pixel, get the float for, which is just a vector, and then you can set the things. And you can collapse that with the notation .rgb, and it will do everything nicely. So if I take an example that's a bit more complicated, where it's the bloom effect. The way it works is that we have to select the bright pixels, you blur the result, and you apply this blurred image back onto the original image. So you get an image like that, and you want an effect like that. In Java, this is what you would do. First, you need to compute the luminance. Then you need to iterate through your pixels, unpack the pixel information, get the luminance, find the pixels that you are interested in, the more the brighter ones, and that's just your selecting the brightness pass of the algorithm. So that's it's pretty complicated. With a GL shader, this is what you would do. Much nicer. You get your pixel. You can apply a dot product on the luminance vector. That gives you an image converted by to brightness. You select via a threshold the pixel you are interested in, and that's what you get. With Renderscript, it's actually very, very similar to the GL shader code. So I just put this example so that you realize that, yes, it's extremely close to shaders. If you know shaders, don't be afraid of Renderscript. The nice thing with this is that if, probably move the slides, but basically if I want to do the rest of the algorithm, I can simply use the intrinsics. I don't have to write a blur myself. I can just, get instances of the script intrinsics, set the parameters, and just call it on the images that I just processed, and that gives me my image. All right, so going back on the photo editor, what you'd like to do is something that works well everywhere. And it is a problem because Android runs on a lot of devices that are very different in terms of capabilities, screen, memory, GPU, CPU. So Renderscript provides a really good option for that because you don't have to deal with the hardware particularly. You know that if you write it, you can use the compatibility library, and that will, you can make sure that things will work. But that being said, it's not a magical answer either. If you just wait for Renderscript, you may not provide a great experience to your user. So my advice would be to architect for, the worst. You try to think that it's going to run on a very, very slow device, and build your UI so that everything happens in the background. The UI should not be interrupted ever. You want a smooth experience, and that's really what you need to shoot for. Of course, you need to take, change things depending on the device capabilities. You may have a different strategy if the screen is much higher DPI. You may have a different cache. If you have a lot of memory, maybe you can really expand on your cache, etc., etc. Basically, try to think about what would be the downgraded experience for your application. There's a couple of things that you can do when you load bitmap as well. First of all, nothing on the UI thread, obviously. So you can run either the loading in an async task, or you can have a background thread, whatever. The point is, don't run stuff on the UI thread. You can do interesting stuff as well when you load a bitmap. So you can query the size, and that basically will not load the entire bitmaps in memory, which is nice. It's pretty fast, and like that you get the size. Another common operation that you can do is subsampling the image. So if you have a very large image that you want to display, and what you display is a very small area of your screen, maybe you don't need the entire image. So you can specify the in-sample size. It's just a power of 2, and that will basically subsample the image. The only trick with that is that it needs to be a power of 2, so you probably need to have a function a bit like that, where as long as the size of the image is not smaller than whatever width you want to go with, you just multiply that and you pass that in the in-sample size. The other option that's since Android 3.0 is that you can reuse bitmaps, which is nice now that the memory for the bitmaps is basically on the Java side. So that's going to count against the rest of your of the memory allocated to your application. So if you can reuse bitmaps, much nicer. There's another operation that's really cool. It's region decoder, and it basically lets you specify just an area of an image instead of having to load the entire image and crop it or anything like that. So we use it in the editor when you zoom and you want to just show the full-size image. You don't want to actually, particularly with very large images, you don't want to load the entire image in memory. So you can just load this particular section, and that's really, really fast. So in terms of the pipeline in the application, we run it as a background service. We also use that for saving and stuff like that. The pipeline runs a mix of filters written in C, in Renderscript, and in Java. The C and Java are mostly for historical reasons because we didn't go back and rewrite everything. The Java filtering is also used because, you can easily apply canvas operation onto a bitmap, so sometimes it's pretty useful. And we've got a bunch of pipelines running in parallel for the preview, the high-res preview, the updating the icons, etc. So the pipeline itself is actually unbounded. So you can pile up as many operations as you want in it. There is no fixed order. So basically the order of the effects in the pipeline is going to be the order you applied the effects yourself. And we've got various different types of filters. So when I said that you did not have a fixed order, I kind of lied because actually we do have classes of filters. So we have got the color effects, which are just color transforms. And that's the one, that's the effect that you see in the first tab of the application when you start. Then you got geometry, then you got all the other filters, and finally you got the borders. So the actual order in the pipeline is most importantly the geometry that will change the way the image is going to be processed via a crop or like a straighten. Then we apply all the filters, and then finally we apply borders. But within those classes, you can have any kind of ordering. The color effects, if you don't know what it is actually a pretty cool trick that's used a lot in games. It's basically a 3D cube that just represents an RGB cube. And if you apply a filter, like even a contrast or a color change, you can basically encode it into that 3D lookup table. And that's very efficient. It's not automatically perfect in terms of precision, but we found out that even very small 3D LUTs gives you a really good result. So caching is another one of those things that you really, really need to do and need to think about. So we do, the obvious. We of course we cache the original images and stuff like that. In general, we try to be very aggressive into what we destroy, because we don't want things to be in memory a lot. Because if you are processing an image that is already very large, you don't really want to have like 10 copies of it everywhere. So as much as possible, all the filters try to process. So that's kind of the concept, the contract that we have with the filters, that they should try to process the input directly. And then we have, we cache stuff in the pipeline. I'll explain a bit. So for the memory usage, what you can do in your application, try to think that you can use a bitmap cache, clearly. There is an LRU cache class that is in the support lib. Feel free to use it. Be careful about the image sizes that you pick. And again, try to think about what's the experience you're going to provide to your users when you are running on a very low-end device. In general, as long as you do stuff in a background thread, and as long as you have bitmap caching and try to reuse bitmaps, you're probably on the right path. So to query the device capabilities, you probably know that, but yeah, you can ask for the memory that is allocated to you. So depending on that, you may decide to degrade the experience. Of course, you need to handle the signals that the system is going to send you if we are running out of memory. And it's pretty basic stuff, but think about that. We do a couple of things with the pipeline cache. So that's the general pipeline model, but of course, in reality, it's probably more something like that. So when the user changes a parameter into, let's say, the last filter, the way it works is that we are going to have to recompute all the images to get the final processed image. That's not exactly optimal. So we are a bit more clever than that, and we just keep the last n-1 image around, so that if the user modify again the same filter, we just have to recompute just one image. That actually scales pretty well. It's not perfect, because if the user modify a filter that is at the beginning of the pipeline, of course, you are not going to do much caching. But it works pretty well, because most of the time users just apply filters and change what they just did. So in terms of real-time interaction, how do we achieve that? Well, lots of background processing, clearly. Be very, very careful about allocating memory. The garbage collection is really what can kill you on the UI. As much as possible, pre-allocate stuff and reuse them. Of course, we've got, the filters are pretty optimized themselves, and Renderscript clearly helps a lot there. And we do some caching in the pipeline. The other stuff that we do is we do the preview system that we have. We basically gives you a preview that is pretty low res, but because it's an image, it works pretty well. And when the user stops changing the parameters, then we switch back to a higher res version. So the preview, the basic model is that it's just a triple buffer, right? So we can process an image in the background thread. If the UI needs to change something, my slides are messed up, we just swap the things, and vice versa for once the image is processed, the processing is done, then we switch it back. So like that, there is no interruption. We do pay the cost of having 3 copies of the preview, but because it's a low res, it's not a big deal. More importantly, we do not do allocation. Then the preview model is basically that we have this continuous preview that is applied as soon as the user is tweaking a parameter, and that's a pretty low res image. When the user stops touching the filter, modifying the parameters, we display an high-res preview. And finally, if the user, let's say, if the user is zoomed in, of course, we compute the intersection with the viewport, and we give you the full resolution of the image. If the user starts changing again the parameters, we just kick back the scheduling for the high-res and full-res preview later on. So the one thing that was very useful and that worked surprisingly well was to make sure that the UI elements themselves were running as fast as possible, and they are running on the UI thread, and well, the UI is hardware accelerated already by Android, so you can pretty easily get very good performances of that. And if your controls are moving at 60 FPS, the fact that your image is lagging a couple of frames behind, it's not such a big deal. The other important stuff is if you have such a pipeline like that, you do need to be able to interrupt it. It's one thing to just say, okay, I'm scheduling a processing on my image. If that process is going to take all of your GPU or all of your CPU for 5 minutes, it's not great if the user just decided to switch back the parameter and you have to wait for those 5 minutes. So clearly, you need to be able to interrupt stuff. Luckily, Renderscript provides a decent option for that. You can pass launch options to the kernels, and one of the options is the ability of setting your range in X and Y. So if I do just an example of code like that, I'm just setting the X and Y for the image just in a checkered pattern, and I'm calling either a gray kernel that's returning a grayed out image, or just a simple kernel that is a pass-through. And you end up with an image like that. So that's pretty nice because you can then easily just check regularly that your processing is not interrupted. If it is, then you stop. There is one gotcha though, is that Renderscript is all asynchronous. You are going to have automatic sync point when you want to access the image, but if you simply try to check while you are doing this loop, you're actually not going to be able to interrupt anything because this is just code that is immediately passed and executes super quickly. It's passed to Renderscript, and Renderscript then deal with it. And it's only when you actually copy the final image back that you have the sync point. So what you need to do in that case is after you have done a chunk of work and you want to look at, hey, am I interrupted? You need to sync to the sync call on the Renderscript context so that Renderscript will finish the operations. So clearly in real life, you are not going to do a checkout pattern like that. That's not going to be very efficient. In the editor, we just do it in a regular rows, and after each row, we check. And that provides a good balance. So for the full resolution preview, as I said, the idea is that we just take the intersection of the image and the viewport. So that's a bit different from the two other preview models with the low res and high res. On those ones, the image is actually passed to the filter as a full image. While for this one, the filter needs to know, in order to be able to process that, needs to know where it is in the image. So on some filters, it doesn't really matter. Like for a color transform, it's the same. Where you are in the image doesn't affect the results. But let's say in a vignette, you do need to know where you are. So we did the modification on some of the filters, not on all. So if you do play with the editor right now, if you zoom on a very high resolution image, sometimes it will look slightly blurry because we actually do not show you the full resolution preview. And on some filters, like the color filters, it will show you the full res. So that's something we are working on. Ideally, for the full res preview, we would not want to have just this get the intersection of the viewport. We would use a bunch of tiles that we can then reuse, so that when you uncover a part, you just have to compute the tiles that are no uncovered, and you can reuse the ones that are no hidden, rather than having to recompute the entire viewport area. The nice thing, though, is that if we do this modification in the filters, modifying them so that they know where they are, then we will be able to implement a streaming save. So right now, when we save, we actually we are simply using the Android framework capabilities, and we need to have the entire image loaded in memory, and then save that as a JPEG. It would be much better if we could just save it as we go along, and that's not done, but we did implement the code to do that, to wrap the libjpeg to do exactly that. It's in AOSP if you want to have a look, or if you want to use it, it's there. So a couple of slides about what's next. Well, what we could do in the photo editor, we could merge filters. There is some capabilities already in Renderscript to specify a bunch of scripts together, consider that as a script group, and then they're not doing any particular optimization now, but that's their plan. They will be able to collapse filters together, for instance, in some cases. So that could be pretty nice. At the pipeline level, we could also do a similar model where if we have filters, consecutive filters that can be collapsed in some way, we would do that. I mean, one possibility would be for global filters to even compute the color, the 3D LUT, the same that we do for the looks, compute that for that filter, and then it's basically like a big matrix that we could just, and we could collapse all of those. We may not want to use that for the final rendering, for when you save the image, but at least for the preview, that might be nice. And of course, implementing the streaming save as I described. So in the Android framework itself, there is a couple of things that I've been playing with lately. So I'm not making any promises, but I'd like to have some input. So one thing that we are considering is possibly adding some filtering capabilities in the framework. Improving the image loader mechanism, maybe adding, that's probably much further away, but color correction or raw support would be really nice. And I'd love a tile view. So a tile view, lets you do things like that, where you have a very large image, a 70 megapixel image, and you can just move it around, and it's smooth. And it's actually just using tiles. So that's what I was describing earlier for the full resolution preview. And you can see here, well, not really because the display colors are not quite correct, but you can see a bit faint green lines. Those are my tiles. And the way it's set up right now is that you have a tile view. It's a normal view. You can drop it anywhere. That use a tile grid, which is hosts a bunch of tiles, getting them from a tile cache. And the interesting bit is that you have a tile view adapter that, just an interface that you can implement, and that looks something like that, where you just get the size of the tile, the size of the content, and then you get a callback that will call you to paint that particular tile. And with that, I'm done. If you want to look at the Renderscript documentation, it's online. The documentation is not perfect, but it's being worked on, and it should improve soon. Otherwise, you can always talk to me after the talk or send me an email. Voilà. If you So, is there any questions? Yeah. So the question is, did I say that Renderscript was not compatible with all the devices? Is that correct? It might not work. No, what I said was that the GPU backend for Renderscript, you need a driver. So right now we have them for the Nexus devices. It's been worked on, and it will probably. We at the beginning of the year we had nothing. So now we've got all the Nexus devices, and manufacturers are working on drivers. So the coverage should extend. But right now, not all devices have the GPU driver. That being said, because there is a compatibility library, you can run Renderscript anywhere. We did run it on a Froyo device. So there is no problem with that. And that's really one of the reasons we picked Renderscript for the photo editor, because all the problem with dealing with OpenGL and making sure that everything works well, we didn't have to really think about that. Any other questions?
I have another bonus question.
Yeah.
What kind of editor do you use to actually do scripts? Does it work with Android Studio?
So the question is, what kind of IDE we are using when we are dealing with Renderscript. Right now, the integration of Renderscript in Android Studio is an ongoing effort. You can edit the script and it works well, but the toolchain is not there. My guess is that that will come pretty soon as well. Eclipse, the integration with Eclipse is there, so you can use Eclipse. Yes? Yes, so the question is, does the tile view have zooming capabilities? That's the idea. I mean, the idea is that the tile view would basically handle all the normal gestures, scaling, swipe and fling and this kind of gestures for you, and you just have to provide this adapter that knows how to paint on a tile. And you just get past the scale factor, and you have to do what you have to do with that. Yeah. Okay, well, if that's all, thanks very much, and yeah, don't hesitate to contact me. Yeah.